Alright peeps, today is our last day of practice before our test, for our geometry test. We're going to be talking about, area of shapes, those two triangle rules that we learned about. Today on the assignment you're going to be practicing a lot of those. I do want to show you guys one last thing. It's called decomposing. Decomposing, when they're talking about it, is really just going to be breaking down a shape into another shape, or cutting off a piece of that shape and moving it. I'll be honest with you guys, there's not a lot of real value to this for 6th grade, but to understand it really isn't too difficult, because really a lot of stuff, when you decompose it, the size of it doesn't change. But the size of the individual pieces don't change. It just turns into a different shape. So first I want you guys to see here, I have a trapezoid. I actually put two trapezoids right next to each other, y'all. These are the same shape, the exact same size trapezoid. I didn't put labels on this side because this is actually going to be decomposed. This line I drew through the middle is supposed to be cutting it in half. So you actually look, I have a triangle up at the top, and I have a triangle down at the bottom. Two triangles. Sorry. So even though I started with the trapezoid, all I did was take my pair of scissors and cut it straight through, or I guess diagonal through the middle. What I really want you guys to realize, though, is none of our values actually change. If you look at these two triangles we have over here, this part of the triangle should still be 10 feet. This does not change just because we cut it diagonally through there. Also, on this bottom triangle, from here to here, if you look, this is all still underneath this one triangle. That's all still the base of that triangle. So that is still going to be 13 feet. The only thing that's kind of, I can't say different, it's just moved, is the height. Before we had the height going straight from the top to the bottom there, and that was 5 feet. If you look, I couldn't go straight from the top to the bottom because that goes from one triangle and down into the other triangle. But if we're just looking for the height, it's really the distance from the lowest point of that triangle to the highest point of that triangle. Let's say I look here on this triangle. All the way up to that top corner is actually still the same height. That is still 5 feet. Y'all, if you looked at this triangle, even though there's just one little point kind of down here at the bottom, from the bottom all the way up to the top, even though I'm measuring it on the outside, it's still 5 feet. The biggest thing to remember, y'all, is to make sure that you're not saying that this diagonal piece is 5 feet. We don't know about the diagonals. That's not height. Our height is the vertical piece. So if you have a dotted line on the outside or a dotted line that's moved over on the inside, that is still going to be the same height as what we started with. The heights do not change. The bases do not change. Height and base. Terrible G. Height and base stay the same. Y'all, even though we moved it or we turned it into a different two shapes, the values stay the same. That's why I wrote it in all caps, y'all. That's super important. I'm about to show you guys another little decomposition of a parallelogram on the other side over here. Let me just move my stuff. Hopefully that light's not in the way. Of course it's in the way. So if you look at this first one, we have a parallelogram here. My top is 20, which means my base would also be 20. My height from the top to the bottom is 5 feet. For this one, we're going to decompose by actually taking off this triangle part from the side. I erased a little bit too much. Taking off this triangle piece from the side. And then we're actually going to re-add that triangle that we cut off from here to the other side over here. If you look, we changed our shape from a parallelogram into a rectangle. But it was base times height. Now it's length times width. If you think, though, if you look, the number of the value is actually still the same. So when you decompose a parallelogram, yes, we took the triangle off this side. We moved it to this side. That was that little piece right there. Kind of a triangle. The little piece right there. But our values, just like with the trapezoid, stay the same, y'all. If you look for ones with the values that stay the same, you should be completely fine on the test, y'all. There's no math to do. There's no reading really to do. You just have to look for the one that has the same value. Y'all, if you have any questions, please let me know. Have a good day today.